All right, here we go. Advent of Code Day 11. Cool, great. So this is a modeling thing. Awesome, I like this. Okay. File. Great, got a list of a bunch of strings that we can index in. Okay, so let's simulate this. So seat layout, floor, empty seat, or occupied seat. Now you just model the people who will be arriving shortly. 14. Okay, if the seat is empty and no occupied seats adjacent to it, seats becomes occupied. Seats, okay, floor never changes, seats don't move. Okay, great. Interesting how the chaos stabilizes and okay, cool. Well, let's do, we're gonna be doing some mutation. So for, well, while true, and we're gonna say changed, or let's just try this first. Changed equals false. While true, new L is equal to this. For line in L, for C in line, and okay, so if C becomes occupied, okay. Let's actually iterate over indices because I think that's going to be a little bit more helpful. For in, so the length, each thing, so R in length of L, range. Oops. For C in range, length L of R. So now we've got our row and our columns, and so now we're going to get one of the 8 positions. Okay, so I wrote a little util to help with this, and this is going to be adj is equal to util.adj 8 of R, C for block in edge. Why am I getting that happening? Okay, so if char is equal to L of R of C, and then we've got you know what this should be? This should be a map. This should be map of. I don't know if I want to deal with that right now, though. We're just going to go through, and I might fix that after. So that's the character. If char is not equal to dot, then this happens. Okay, if a seat is empty and there are no occupied seats adjacent to it, 4 or more adjacent. Okay, cool. So let's just count the number of filled adjacent seats. So to count that, yeah, I think I'm going to change this to a map because I don't like having to check a whole bunch of things. So this is going to be a little bit of a switcheroo. Let's just say seats is equal to this for line in L, or let's see, no, it's going to be almost exactly this for loop. And then it's going to be seats of this, R comma C, is equal to L of R of C. Okay, and this is what I actually want. So now we iterate through each of the locations in this set. New seats is equal to this, and now we're gonna say for loc in seats, and then we do this stuff here. I like this a lot better. Okay. Oops, this should be tabbed in. Okay, character is equal to seats of location. If character is not equal to dot, adjacent is equal to else. New seats of lock if lock in seats and seats of, we're nesting our lock, so there's going to be lock 2. If lock 2 in seats and seats of lock 2 equals empty is L, occupied is a hash, then filled plus equals 1, and now if filled, if it's empty and no occupied seats, becomes occupied. Otherwise, the seat state does not change. If filled is equals 0 and the seat is empty, char equals L, new seats of lock equals, and this should be just single equals. So it's empty, then it becomes occupied. Elif filled equals or greater than equal to 4, and char equals hash, then new seats of lock equals L, else new seats of lock equals seats of lock. Okay. Seats equal to new seats. Let's just simply enough just print the number of occupied seats here. For lock in seats, count. This is going to be just a, I know there's a quicker way of doing it, but I'm just going to do this quickly because I know how to do it. Seats of lock if $7,100. Dang it. Okay. Something's not quite right. Okay. Well, let's try it with our smaller set here. That's why. Whoops. This needs to change. And it's doing stuff. 2247. There we go. 192. We're doing great. Okay. As soon as people start to arrive, you realize your mistake. People, they care about the first seat they can see in each of those 8 directions. Oh, goodness. Okay. Let's see 8 occupied seats. Wow. Okay. The leftmost empty seat would only see 1 empty seat, but cannot see any of the occupied ones. Okay. Okay, well, let's just copy this, and since we didn't end up using the changed, we'll just give this a try. Okay, so now the main thing that's changing here is just this adjacent thing. So let's just write a new function that finds the next seat in that direction. So def visible 8 of location and seats. And let's just call it S. Okay, so now what we need to do is kind of the vectors that we're going to be working with are -1, -1. Actually, it's just going to be util.edge8 of 0, 0. And then what we're going to do is we're going to have to iterate through each of those directions. So now we're going to say count is equal to 0 for v in vex while true, we're going to say new lock is equal to lock, and we're going to say, okay, while true, now we want to say new lock is equal to util.vecadd of new lock and v, and we're going to say if new lock, or s of new lock, well, if new lock in s else break. So if it contains this new location, we now need to check to see what's there. So if it's a floor, okay, if it's a floor, we continue. If s of new lock equals dot, so the only cases we need to worry about is if it's L, if s of new lock equals hash. So if it's L, we know it's empty, so we just break. And if it's not empty, we say count plus equals 1, break. Okay. Actually, we just do this. So filled is equal to visible seats. Okay, and then we forgot to return count. Filled is greater than or equal to 5. Come on, converge. 2011. Woohoo! Nice. Cool. Well, what we need to add is some convergence stuff, just so that we don't have to deal with all of the just letting it run until it stops thing. But I think we did pretty solidly. Let's see what was coming up before the 2011. Yeah, it was just a bunch of random stuff. And if it ever repeat, I guess the thing that surprises me is I feel like it can repeat numbers while still changing. So that's one thing that we need to watch out for. So we need to make sure that the actual seating arrangement is the same, which I think we can do by having a little toggle that goes off when, oh, that means it flipped. Oh, that means it flipped. And if neither of those things happen, then we can just say, yeah, we're fine. Okay, let's look at leaderboard stuff just because I'm curious. So day 11, first guy 427, 14 minutes to get into the top 100, and 8 for the first part. And for me, I was 2 minutes off and a minute off. But I did well on part 2. I got that faster than I moved up almost 60 places. That's exciting. Great. Second best day by far to be under 200 for both parts. Now let's go through and clean this up. So what we want to do is we want to see if the seating arrangement has changed at all. So I think we are going to actually use this little changed toggle. And what we're going to do here is we're going to say change. So while change, and we're going to say change is true. While changed is false. And then we're going to say changed is true. Changed is true. And then what we really want to do here is after it's not changed, then we do this thing right here. Count is 0 for each location. Then we so we should fix this as well. I know there's ways of counting values in maps. Let me just Google it. Python count map values. Let's just try putting count, and I also want to print Python count. Okay, so I think we want to pull out the values. So I think we want to do seats.count or seats.values count hash. Okay, so let's turn this into a list. Hey, that's what we want. Cool. So we can ditch that. Yeah, I was very glad that we did this because iterating, like just checking if something's in the map is so much easier than like, oh, well, is the line in the list and is the character in the line? Cool, so I'm pretty happy with part 1. So now part 2, we've got to do something similar where we say change equal to false. I think we actually just do this exact same thing. This makes me think that we can do these two sections exactly the same with the exception of changing this number and changing how you get the filled number. Yeah, okay. Let's make a function. And this function is going to be def simulate seating, and we're going to hand it the filled func, and we're going to hand it max surrounding, and that's going to be the value that goes here. And then we're also going to give it the seats. Or, yeah. Okay. And tab. Okay, so now we want to return that here. I just really don't like seeing repeated blocks of code. So now what we want to say is just filled is equal to, we're going to assume that the filled function takes in location and seats. And then this number right here is going to be max surrounding. And cool. So let's try doing this here. I'm going to comment out all this garbage. Well, actually, probably be easiest to, okay, I have to write another function that is def cool. Okay. So now what we want to do is comment out these guys. And now what we'd like to do is just call simulate seating with those two separate functions. Filled func, so this is the part 1 is going to be adjacent 8 filled, and max surrounding is 4, and then seats is just seats. And then this is going to be visible 8 filled, 5 seats. And it's not going to work on the first try because it never does. Wait, part 1 worked on the first try, and part 2, I think it gave me my, is that the answer that I got? 2247, 2011. Huh, what do you know? So let's figure out why it's not quite, why it's being a little funky with what it's printing. Let's delete that guy. Where's the none coming from? That's weird. Because I only have 4 prints, don't I? Oh, there's a print. That should not be there. And there's 6, yeah, okay. Oh, I'm not returning a value. Oops. This should be return. Cool. Okay, it's a little slow. I'm wondering if we can speed it up a little bit. Pretty satisfied with this. I mean, we've now made it the two parts pretty well merged because the distinction is how you count the adjacent seats. So I'm pretty happy with this, and I'm going to get this pushed up to GitHub, so check it out there if you want to play around with it. And you will get another video tomorrow. Goodbye.